This process covers the development and criteria for establishing profiles for BGA component removal and replacement. The minimum skill level needed to complete this procedure reliably is advanced. The conformance level reached when this procedure is completed properly is high. See the web page for a list of the tools and materials required to complete this procedure. A caution about operator safety. A thorough review of the equipment manual and comprehensive training are mandatory. Daily maintenance is essential. Consult the equipment manual for more information. A caution about component sensitivity. This method may subject the component to extreme temperatures. Evaluate the component's tolerance to heat prior to using this method. Plastic BGA components are especially sensitive to moisture absorption. Carefully evaluate pre-bake requirements. A caution about circuit board sensitivity. Circuit boards are made from a great variety of materials. When subjected to high temperatures, they are susceptible to the following types of damage. 1. Layer delamination. 2. Copper delamination, separation of pads, barrels of inner layers. 3. Burns and solder mask chipping. And 4. Warp. Each circuit board must be treated individually and scrutinized carefully for its reaction to heat. If a series of circuit boards are to be reworked, the first several should be handled with extreme care until a reliable procedure is established. Note: this procedure references temperatures used when processing BGA components soldered using tin lead solders. Temperature adjustments may be required when processing components soldered using higher temperature lead-free solders. The procedure follows. Procedure: General instructions. Step 1. Note: your solder paste manufacturer will have a recommended time temperature curve for these applications. It is recommended as guidance for profile development. Step 2. One fully assembled development board is required. Step 3. 4 to 6 sample BGA components for development may be required. Step 4. A steady-state operating temperature or threshold must be established prior to launching the reflow cycle. A consistent temperature starting point is necessary for repeatable results. Between 110 and 140 degrees centigrade is recommended. BGA soldering profile instructions. Step 1. Note: the BGA replacement profile may require more time and even more heat, usually not more than 20 seconds time, to not only reflow all joints but to properly evacuate flux gases and create uniform joints across the package. Step 2. Insert thermocouples into the holes. Ideally, the thermocouple is secured in place by the solder of the pad that the thermocouple is placed in. Otherwise, secure in place with high-temperature tape and thermal adhesive. Additional thermocouples will also be placed on the top of the circuit board, about 2 inches from the site, and on the bottom side under the site. These thermocouples may be taped in place. Step 3. Select an appropriate nozzle and install. Be mindful of the component height and clearance area around the component. Step 4. Secure the circuit board in place with appropriate tooling, clamps, and pins. The circuit board should be secure but allowed to move with thermal expansion. Anti-static solder wave fixtures may be used to prevent warp. Step 5. Connect the thermocouples to a temperature recorder. Connect other monitoring thermocouples to handheld digital thermometers as required. Temperature recorder should present a graphic display. Step 6. Select soldering process parameters from similar existing profiles. If none are available, contact the manufacturer of the rework station. Note: it may be advisable to shut off all vacuum commands when developing a removal profile to prevent inadvertent component removal. Note: pre-bake the circuit board to drive out accumulated moisture. The length of pre-bake will be affected by the circuit board's environmental exposure. A pre-bake temperature of 75 to 100 degrees centigrade is recommended. Step 7. Place a pre-baked circuit board onto the fixture. Step 8. Establish a bottom side under part threshold temperature from which to begin the reflow ramp. 140 degrees centigrade underneath the component should correspond to approximately 90 degrees centigrade at 2 inches from the nozzle on the board's top side. Choosing a starting point in this approximate temperature range will help to reduce localized warping during BGA ball reflow. Step 9. Run the process and monitor the temperature of the bottom and top of the circuit board, next to and under the component. Step 10. Disconnect the thermocouples and download the recorded data. Step 11. Analyze the data and optimize parameters for a reliable rework as follows. 1. Maximum temperature at the solder ball board pad interface should be 205 degrees centigrade. 2. Minimize the temperature differential to less than 15 degrees centigrade for internal thermocouples measuring the various solder ball board pad interface. 3. Time above 183 degrees centigrade should be between 30 and 60 seconds. 4. Temperature rise and fall should not exceed 3 degrees centigrade per second. Step 12. Make changes to process settings as applicable. Step 13. Run the process. Step 14. Examine the surface under the component for warp. Note: excessive localized warp may be reduced by increasing the preamp temperature threshold. A convection oven can be used to decrease the thermally induced stress caused by the process. Even heating across the entire circuit board may be required. Develop the removal process. Note: the component will typically release from its pads when two of the thermocouples measuring joint locations pass the 183 degrees centigrade mark. In order to reduce mask, part, or circuit board damage due to excessive heat, the removal cycle is typically shorter than the replacement cycle. Reflow the joints just enough to effect removal. Step 1. Copy the parameters of the soldering profile to develop the removal profile. Step 2. Change the process parameters as needed. Step 3. Connect the thermocouples to the temperature recorder. Connect monitoring thermocouples to the handheld digital thermometers. Step 4. Run the process and monitor the externally connected thermocouples. Step 5. Disconnect the thermocouples and download the recorded data. Step 6. Analyze the data and optimize parameters for reliable rework as follows. 1. Maximum temperature at any location should be 210 degrees centigrade. 2. Minimize temperature differential to less than 15 degrees centigrade for internal thermocouples. 3. Time above 183 degrees centigrade should be between 30 and 60 seconds. Step 7. Adjust the process parameters as needed. Step 8. Determine the time in the process when all component ball locations reach 183 degrees centigrade. Note the bottom side monitoring thermocouple temperature. Step 9. Reconnect the thermocouples. Step 10. Inject flux under the component. Step 11. Run the process and lift the nozzle 3 seconds after reflow has been reached. Step 12. Remove the component using the vacuum tool. Note: if software controls the vacuum, select the vacuum on command for all events. This will lift the component as soon as reflow temperatures have been reached. Step 13. If the component cannot be removed, analyze the temperature data and adjust the parameters. Then return to Step 10. Step 14. Inspect the BGA component footprint area for signs of unexpected overheating, solder mask or pad damage.